In this video, we'll talk about most common Kubernetes deployment strategies. If you're just getting started, most likely you're using default rolling update strategy. Not only does it allow you to upgrade your apps without downtime, which is very important, but you can also adjust it to fit your needs. Next, we'll talk about recreate strategy and the use cases when you might want to use it. If you work in a large organization, you'll want to minimize the risks during the upgrade. For that, we frequently use blue-green deployments. If something goes wrong with a new version, we can easily switch back to the old deployment. Another approach you can take to minimize risks is to use Canary deployment. With a blue-green deployment, we typically shift 100% of the traffic to the new deployment and hope that we don't have any bugs. With a Canary deployment, we can only shift a small percentage of the traffic to the new version and start testing. Then we can gradually shift more and more traffic until we reach 100%. To implement all these deployment strategies, you can use native Kubernetes objects such as deployments, services, and pods. And I will provide real-world examples that you can apply in your work. Also, I'll show you how to automate all these deployment strategies with service mesh networks such as Istio, Prometheus, and Flagger. You can find the source code and instructions in my GitHub repository. Finally, we'll cover more advanced deployment strategies such as shadowing and A/B testing. Now, let's start with the default rolling update deployment strategies. This is one of the most common types of deployments since it allows you to upgrade the application gradually and, most importantly, without downtime. If you don't configure the strategy section on your deployment object, you'll get these default settings. Type rolling update, max unavailable 25% and max surge 25% as well. So what does this mean? Well, a rolling update means that Kubernetes gradually replaces old pods with new ones. Max unavailable specifies how many pods can be down at the same time. The default is 25%. Which implies that up to 25% of your pods can be down at any given time. If you have 4 pods, only 1 pod can be down at a time. If you have 10 pods, 2 to 3 pods can be down at any time. Next is max surge, which is also set to 25% by default. This parameter specifies how many additional pods can be created over the desired size of the deployment. So the total number of pods at any given time cannot exceed 125%. Therefore, if you have 4 pods, only 1 can be created over the desired size. If you have 10 pods, 2 to 3 additional pods can be created. You can use percentages relative to the deployment size, or you can use integers. For instance, if you want a very slow deployment, you can specify that only 1 pod can be unavailable and only 1 can be created above the desired size. In this case, you'll get a very slow but safe rollout strategy. It's also important to note that you have to provide health checks for the rollout to successfully upgrade your app. I'll create a dedicated video soon explaining all the different types of health checks you can define in Kubernetes. Now, let's do a demo. If you want to follow along, you can use Minikube, run Minikube start and optionally specify the Docker driver. Next, run kubectl get pods in the default namespace. Optionally, you can use watch command to refresh it every half second. The default is 2 seconds. This is our deployment that uses default rolling update strategy and settings. We have 4 replicas. I added a startup prop just to simulate a real bootstrap. You can also use my Docker image, which is compiled for both ARM and AMD architecture. We also have a cluster IP service to test the version during the upgrade. Next, apply the deployment as well as the service object. Due to the startup prop, it takes 20 seconds before we can start testing our app. For the test, let's spin up a pod based on the Alpine image in the kube system namespace. It has curl that we can use to hit our application. Next, let's run curl in a loop and sleep for 1 second after each try. Right now, we have the V1 version returned by our application. Let's update the deployment to the V2 version. Apply the deployment object. Now you can see that we have two new pods with the V2 version, and the total number does not exceed 5 pods. As well, based on max unavailable setting, we have 3 pods running with the old version. During the upgrade, curl can get stuck with a timeout, so you may need to restart it to get a new version. Alright, we're getting replies from the V2 version, and if you wait a little bit longer, Kubernetes will complete the upgrade. I want to show you another useful command. This time, let's update rolling update settings and use integers instead. Also, set replicas to 10 pods. This will give us some time to play with the deployment. Let's go ahead and apply this second deployment object. Now, kubectl has a rollout subcommand that you can use during the upgrade. It can be combined with deployments, stateful sets, and daemon sets. It's useful because you can pause the upgrade, restart, resume, and even undo to roll out back to the previous version. Let's see it in practice. As always, let's update the version of our app. Reapply it to trigger the upgrade. Now, if you simply get the deployments, you'll see the upgrade process. For example, we have 2 new pods and 9 pods are available for this deployment. If you run status, you can get pretty much the same information, but in human-readable format. 2 out of 10 replicas have been updated and so on. Let's say that during the upgrade we discovered a bug in the new version and we want to immediately stop the upgrade. For that, you can use rollout pause command. It will simply stop the upgrade and we still have 2 running versions of our app. Now, let's say it was a false alarm and we decide to complete the upgrade. For that, we can use resume command. It will finish the upgrade and roll out the new V2 version to all our clients. Let's say we spent more time testing this new version in production and finally decided that we have a bug. So to downgrade the app to the previous version, we can use undo deployment command, and Kubernetes will roll out our previous V1 version. In practice, I always use GitOps approach, and if I need to downgrade the app, I would create a new commit in Git and wait until Argo CD or Flux handle the rest. But these built-in Kubernetes capabilities to pause, resume, undo can be useful when you're building Kubernetes operator and can leverage this during the life cycle of your application. Another useful command is restart, which I definitely use during the blue-green deployment to restart and shift all the traffic to the new version. We'll go over it later in the tutorial. The next type of deployment is recreate. This one can be dangerous because it can cause downtime. No matter how many pods you have under that deployment, when you trigger the upgrade, all of them will be immediately terminated and replaced by new ones with a new version. This type is frequently used in development when you don't really care about downtime. If you introduce a bug with a wrong upgrade, your deployment can get stuck due to the crash loop. But with recreate, every time you build a new image, your deployment will be immediately upgraded. Another use case potentially in development is when you have limited resources. Let's say you have a single node that can run a single pod. If you perform a default rolling update, your new pod will get stuck in pending state and won't upgrade your app to the new version. With recreate, it will terminate that pod first and then start a new one. The last one that I can think of is when you run a deployment and attach a volume with read-write once access mode. That means you can attach the volume to only a single pod. If you try a rolling upgrade, Kubernetes will create a new pod first and then try to attach existing volume to the new pod, but will fail because it can only attach it to a single pod. A real-world example would be Grafana deployment. Now let's quickly go over recreate demo. We have exactly the same deployment object with the same image, but in this case we define recreate strategy with 4 replicas. Let's go ahead and apply it. It also takes about 20 seconds for the pods to become ready due to the startup probe. Let's update version v1 to v2 and reapply it to trigger upgrade. You can see that Kubernetes immediately terminates all pods managed by that deployment and create a new set of pods with v2 version. Like I said, this type can cause downtime, but it is useful in some cases. Now, in large companies, we need to be very careful when updating applications in production. One way to minimize the risks is to use blue-green deployment. Blue and green simply mean different versions or configurations. They could just as well be called red, yellow, black, white. The terminology does not matter. Most importantly, in such a deployment, for example, the blue could currently be serving real traffic to real clients, and we might have another, the green, on standby, or vice versa. When you provision a new green version, if it's possible, you could ask your QA team to verify it before we switch traffic to that version. Also, if you have automated tests, you can run them as well. Once QA verifies that the new green version is good, we can switch traffic to it. In Kubernetes, I'll first show you how to use native Kubernetes objects. For example, each pod can have additional label, such as replica. When we're ready to switch, we simply update the replica label from blue to green, and all traffic goes to the new deployment. Then we closely monitor the deployment for some times, which could be a matter of minutes, hours, or even days. If we discover any bugs in the new deployment, we can easily switch back to the previous blue deployment. However, if we're confident enough in the new version, we can tear down the old one. Another use case for blue-green deployment is if you need to evenly distribute your devices across your instances. If you do rolling update, the first two instances will get 5,000 devices, and the last one will get 0, at least at the beginning. But if you switch to a new blue deployment, the devices in this case will connect evenly to all instances. Now let me show you how to perform blue-green deployment using native Kubernetes objects. Here we have a blue deployment with 2 replicas using v1 version. This deployment is currently active. Next, we have another green deployment. We also have 2 replicas for this. In this case, the deployment uses the new v2 version. Most importantly, each pod should have a replica label. For the green deployment, this should be set to green. And obviously, the blue deployment should have a blue label. We also have a service which serves as a gateway to our pods. As of now, it only selects the blue pods from the old v1 deployment. Optionally, you can create additional service that can be exposed to your QA team for functionality testing. In the top window, let's continuously watch the pods in the default namespace. In the bottom window, we'll apply the YAML located in the native folder. If you immediately retrieve endpoints, you'll notice that there are no IP addresses yet, because the pods are not ready. If you wait until they're running and check again, you'll see only 2 IP addresses, both of which come from the blue pods. Thus, our service selector currently only selects blue pods, which is precisely what we want. You can also use Alpine image to test the upgrade. By running a curl in the loop, you should receive only v1 version in the response. Performing a blue-green deployment is as easy as updating a single label from blue to green in our service. Then Kubernetes will update the endpoints object and shift traffic to the new green deployment. Even if you use ingress, updating the service behind that ingress will redirect your traffic to the new deployment as well. Let's go ahead and apply these changes. You'll immediately see that we start receiving the v2 version in the response. That covers the basics. Up next, we'll automate this process. Now, in this video, we'll go through the Flagger demo. However, since setup a bit complicated, given that we need to install Istio, Prometheus, Grafana, Flagger, and other components, the next video will cover a step-by-step installation and provide detailed explanation, along with diagrams of how those components work together. So if you fail to reproduce this demo, wait for the following video. First, we need a namespace with Prometheus and Istio labels. Then we have a deployment, and we also need Istio monitor label to scrape metrics, service object, and the Canary custom resource provided by Flagger. It's still a blue-green deployment, it's just a subset of Canary. You'll see it later. We can select the provider. In this case, we want Istio. We also need to select a deployment object. Then we have the analysis and metrics section. Finally, we have a webhook to load test our new green deployment. To see the progress, you can follow the Flagger logs. Let's monitor the staging namespace and apply the Flagger folder. When you apply, Kubernetes first creates a regular deployment. Then Flagger notices the deployment and creates a primary deployment, which is a copy of your active deployment. After Flagger initializes it, it will terminate original deployment. You can check Canary custom resource. First, you'll want to wait until the Canary transitions to initialized state. You can also obtain this information from the Flagger logs. Alright, the deployment was initialized and we're ready for the blue-green deployment. Now, let's go ahead and update the version to v2. But before we apply, let's run Alpine image as well. Run curl, but this time it's in staging namespace. Now we can apply v2 version. Flagger will create a new green deployment and start testing using the load tester service. In the logs, you'll see that it needs to go through 10 iterations until Flagger marks this deployment as healthy and switches traffic. Flagger also comes with Grafana, where you can monitor the success rate. In this test, if it's higher than 99%, Flagger marks it as healthy. If you wait maybe another 15 minutes, Flagger will shift traffic and terminate the previous blue deployment. Now you can see the v2 version in the response. In the next video, I'll cover it in details, how it works. Next is a Canary deployment. It's also one of the most common deployment types. In this case, we need to prepare a deployment and start slowly shifting traffic to that new version, continuously testing. So if we discover a bug during the rollout of this new version, this approach helps us to minimize the affected users. However, if the results look good, we can gradually route this version to more clients until we reach 100%. First, we'll do it manually using deployment and a service. Then I'll show you how to automate it using Flagger. If you decide to use native objects for Canary deployment, we would need to adjust the replica count to increase or decrease traffic to the Canary. Let's set it to 10 replicas for now. We also have a typical service object without any additional selectors. Let's monitor pods in the default namespace. Then apply the deployment and service objects. Now we have 10 pods running. To start shifting 10% of the traffic to the new Canary v2 version, we need to create another deployment with a single pod. Since we have 10 pods for the v1 version and 1 pod for v2, we roughly shift 10% of the traffic. To shift more traffic, simply increase the number of pods under the Canary deployment. For instance, if you want to shift 50% of the traffic to the Canary, we would need to scale it to 10 pods. Also, we can scale down the v1 version to 0, completing our upgrade. To gradually shift traffic, we need to manipulate the replica property, which isn't very convenient. Istio allows us to shift traffic without adding or removing any pods. The next approach will involve Flagger and Istio. It's very similar to the blue-green deployment. In this case, we just need to define the steps. For example, we might start slowly with 5% and move to 50%, and then if the success rate is higher than 99%, we completely roll out the new version and terminate v1 deployment. Let's proceed and apply it. First, we need to wait until Flagger initializes deployment and removes the original. Then we can update the deployment to V2 version. Optionally, you can also monitor the logs. Flagger will then gradually start increasing the traffic until it reaches 50%, after which it will terminate the old deployment. In the next video, I'll go step by step and explain each parameter you can configure in the Canary or blue-green deployment using Flagger. Thank you for watching, and I'll see you in the next video.